Hey guys, sorry I'm not there today. I'm still feeling under the weather. But we need to get through this lesson because you guys have a test coming up. So don't forget, next week on Tuesday, we've got the skills quiz. Okay, on Thursday, we've got the review day. Okay, and I'll give you the review packets on Tuesday so that you can have them ahead of time. And then the next Monday is our exam 3. Oh, I can't spell. Jeez Louise. Sorry guys, my brain's not functioning. Okay. Exam 3. So make sure you let me know if you're gonna miss that because you will need to take the test early. Yeah. All right. So let's just get into the lesson for today. So first we're going to talk about two-way tables. These are just kind of a useful way to organize data. You've probably seen them before. You've probably seen them before in Math 2 when we did our probability unit. So hopefully this module is kind of familiar from Math 2. So just a couple quick reminders. We have in this, if we look at this table on the left, this is a table with students' grades and their gender. So we have male and female, A, B, C. Okay, so at the bottom here, these are the total students who got A, B, and C. Okay, and then on the side here, we have the total male students and total female students. Okay, and right here, 85, this is our total number of students. So if you add the total of the grades together, it equals 85. If you add the total male and female students, that also equals 85. Okay, do not add them twice, right? Don't add all the bottom and the sides together because you'll just end up with double your number. So both the bottom and the side should both add up to the same thing, and that would be your total. Okay, and then inside our table, we just have, like 8 males got an A and 20 females got a B, right? It just has kind of the breakdown. So we're going to talk about finding just some probabilities. And it's not too hard, so I think I'm just going to go straight over to the example over here. But if you're a little confused, you can read through the rest of this example. So on the right, we've got a test given to a group of students, their grades, and then their residency is summarized below. So I assume they're at a college or something. So we have students who live in state, students who are from out of state, and then their grades on the tests. So we want to find the probability of a student being out of state. Okay, so we just go look how many of our students are out of state. That would be 27. Oops. So we have 27 over the total number of students, which is 65. Okay, and then let's check if that simplifies. Remember on your assignment and on your test, you're going to need simplified fractions and or decimals. It'll tell you what to find. So this one doesn't simplify. The decimal would be about 4154. Oops. Okay. All right. So now next one, probability of someone getting a C. Okay, so a C, we have 20 total C's. So that's going to go on top out of our 65 students or 65 scores. Okay, and then we need to check if that simplifies, and it looks like it does. We get down to 4 over 13. Okay, and then if we change that to a decimal, That's going to be 3077. Okay, and again, you can just type these in your calculator. Don't forget you can simplify using your calculator, right? Just type in the original and then hit math, enter, enter, and that should get you the simplified version. Okay, next we have the probability that it is not an A. So that is basically everybody who did not get an A, right? Oh, good, my screen is frozen. Oh, there we go. Jeez Louise. Guys, I'm having a day. Okay. Probability of not an A. So, there's kind of two ways you can look at this. You could go, well, everybody who didn't get an A either got a B or a C, and you can do 38 plus 20 out of your 65 students. Another way you could do it is think, well, 7 people got an A, so you could do 65 minus 7 to get rid of those 7 people who got an A. Either way, you should get 58 over 65, which I don't think is going to simplify. Let me double check. Yeah, no, that doesn't simplify. So that would be your fraction, and then your decimal would be 8923. All right. Okay, now we have in-state and a B. Okay, so all the students who are from in-state and who got a B. So these ones are, before when we did the and probabilities, we were multiplying things together, right? And you can do that. You can find the probability of an in-state student, right? You could do 38 over 65 times the probability of getting a B, which is also 38 over 65. Okay, you can do that, but when we have a two-way tables, it's actually quite a bit easier. All we have to do is go to the box of all the in-state students who got a B, right? So we go in-state and B, that would be 20 out of our 65 students. So that's why I kind of like two-way tables. I feel like they make things quite a bit easier. Okay, this one simplifies down to 4 over 13 like we had before. And we'll have that same decimal we got before as well. Okay, last thing is our OR. So again, this one has a couple different ways. When we did our probabilities, our OR probabilities before, we would do like the probability of A plus the probability of B minus the probability of both, right? And you can do that. So we could go out of state is 27, out of 65, plus the probability of getting a B is 38. Oh wait, sorry, it's getting an A, not a B. So 7. And then minus the probability of people who were out of state and got an A, that would be 4. Okay, so that's one way to do it. And then the other way to do it is to kind of think about, I just want anyone who's out of state or got an A. So as I go through my we have just go by box. This first 3, they got an A, so I would include that. Okay, the 4, are they out of state or got an A? Yeah, they got both, right? Okay, next we have in-state B. Are they out of state or got an A? No, so we're going to skip 20. Out of state for 18, so that one's good. Okay, and then for the C's, again, we just want the 15 is in state and didn't get an A, so we don't need that. And the 5 is out of state. And then you can add those 4 together, right? So these are everybody who is either in state or, out of state or got an A or both. Okay, and then you can just add those guys up together. So 3 plus 4 plus 18 plus 5 over our total students, which is 65. Okay, you should get the same thing either way. I don't care how you do it. It is up to you. Let's see, when we add those together, we get 30 over 65. And then that is, 6 over 13. And let's check our decimal. 4615-ish. All right, so that's the main thing with two-way tables. I think they're pretty easy. Okay, so now we're going to talk about conditional probability. With conditional probability, a lot of times we have a table, sometimes we don't. We've kind of already done conditional probability a teeny bit. So if we look down here, when we were doing like choosing something without replacement, so like the probability of picking 2 aces without replacing one, we would have 4 out of 52 for the first one, right? And then we take that out of the deck and there are only 3 out of 51 left. So that second one was a conditional probability. It was the probability that we drew an ace given that we have already drawn an ace. Okay, so when you see this notation, this is our conditional, and this line right here means given. Okay, so the probability of B happening given that we already know A has occurred. Okay, so whatever comes second, that has already happened and we know that has happened. And to find this probability, you just do the probability of A and B, so the probability of both of them happening over the probability of A. Okay, so we have both on top, and then the A on the bottom, or the second one. Okay, whatever is given, that's what goes on the bottom. So let's do a couple examples. Don't worry about this other stuff that's in that box. Okay. So in an effort to make this video shorter, I'm gonna ignore this left example. Look at it if you want. You can click on the video up here if you want more info on this one. Okay, so let's just look at the right. We have a test was given to a group of students. The grades and residency are summarized below. I think this is the same table we had up above. Use this information to find the following probabilities. So find the probability that someone is in state given that they got an A. Okay, so we know they've gotten an A on their test, and we want to find out of all the people who got an A, what's the probability that they're in state. Okay, so a couple ways to think about this. The first is to use the formula. So we go to find the probability of both of these. So in state and got an A would be a 3. Okay, out of the total of the second one, so the total people who got an A, which is 7. Okay, and then you're done. The other way to think about it, you get the same thing, it's kind of similar. You can think about given that we know they got an A, so we're only looking at our A's. We want to find the probability that one of them is in state, so that would be our 3 out of 7. Okay, that's just another way to think about it that's a teeny bit different, but kind of the same. So 3 out of 7 is not going to simplify. So let's find our decimal. 4286. Okay. Let's see. Yeah, I'll do this one and then I'll have you guys try the next one on your own. So, probability that someone got an A given that they are in state. So we're looking at all the in-state scores. Okay, and we want to find the probability that they got an A. So both in-state and A would be 3 over the total in-state students, which is 38. Okay, let's see. Does that simplify? It does not.